You know, in the world of software engineering, a single tiny bug can bring a whole system crashing down. For years, the dream, the absolute holy grail, has been to build an AI that can just dive into a complex codebase it's never seen before and fix it. But is that even realistic? Well, let's find out. I mean, this is the big question, right? It's exactly what benchmarks like SWE-bench are designed to test. They basically throw a real-world GitHub issue at an AI and say, okay, go ahead, write a patch that actually works. And let me tell you, it is incredibly hard. So hard, in fact, that until now, the entire field was pretty much split on how you should even begin to tackle it. That's right. For the longest time, you kind of had to pick a side. There were these two completely different philosophies for building AI software engineers, and everyone just assumed they were incompatible rivals. You were either in Camp A or Camp B. So what were these two different paths? Well, on one side, you had what we're going to call the planner, and on the other, you had the improviser. Okay, let's break this down. Think of the planner, or the agentless method, like a chef who follows a recipe to the letter. It has a fixed, rigid workflow. Step 1, find the bug. Step 2, write the patch. Done. It's super structured, which makes it easier to train. But then you've got the improviser, or the SWE-Agent. This is more like a creative chef. You just give it a kitchen full of tools and say, figure it out. It can interact with the code, explore things, and adapt its strategy over multiple turns. So you get all this flexibility, but man, is it a lot harder to train. So for a while, the field just saw this as a trade-off. You had to pick one. But then this new paper, Kimi-Dev, came along and just completely challenged that whole assumption. The researchers behind Kimi-Dev basically looked at this whole planner versus improviser debate and asked a really simple but profound question. What if we're looking at this all wrong? What if they aren't rivals at all? And this was the big, radical idea. What if the structured recipe-following planner wasn't actually the end goal? What if it was more like a boot camp? A way to drill an AI on the absolute fundamental skills it needs before you let it loose to become a flexible, improvising agent. So here's how their two-step recipe works. First, you put the model through a really rigorous boot camp using that structured agentless method. This is where it just learns the basics, the fundamentals, in a very controlled setting. And only after it's mastered all that, you move on to the field test, where you adapt it into that free-roaming, multi-turn agent. Okay, so how does this actually work in practice? Well, the researchers developed this super detailed training recipe that focused entirely on that first boot camp stage. The whole point was to instill what they call skill priors. Now, skill priors might sound a little academic, but it's really just a term for the core building blocks that any good developer needs. You can think of it like developing muscle memory for coding. Instead of trying to teach an AI to solve some huge, complex problem all at once, you first drill it on the small, fundamental skills, one by one. And what are these skills? Well, first up is bug localization, which is really just about finding the needle in the haystack, right? Pinpointing the exact file that needs to be fixed. Second, there's code repair, actually writing the code that solves the problem. And third, and this one is so crucial, is self-reflection, the ability for the AI to look at its own work and check if the solution is actually correct. So after this really intense bootcamp, the result was Kimi-Dev. And here's the kicker. Just by itself, within that structured planner world, it was already a total champion. How good was it? It hit a 60.4% resolve rate on the SWE-bench Verified benchmark. Now, that score made it the absolute best performing workflow-based model out there. So yeah, the bootcamp was a huge success, but the real test, that was still to come. And now we get to the really exciting part, the climax of the story. Did all those skills learned in that structured discipline bootcamp actually transfer over when the model was finally let off the leash? This is the make or break question for this entire experiment. Because if the answer is no, well, then the two methods really are just separate worlds. But if the answer is yes, then it completely changes the playbook for how we train AI coders. And the answer was a huge, resounding yes. After just a little bit of adaptation to turn it into that flexible improviser agent, Kimi-Dev scored a 48.6% pass rate. That put it right on par with Claude 3.5 Sonnet, one of the best proprietary models in the world. The skill transfer didn't just work, it worked beautifully. And what's just absolutely wild is how little adaptation it actually needed. The researchers only had to fine-tune it on about 5,000 publicly available examples. This wasn't some long, drawn-out, expensive training process. Nope. The boot camp had already done all the heavy lifting. To really put that efficiency into perspective, just think about the sheer amount of data needed. A standard base model needs a massive amount of training data to get to its peak performance. But Kimi-Dev, because it already had all those bootcamp skills baked in, needed something like 32 times less data to get to that same level. That is just a staggering improvement. So, what does all of this mean for the future of building AI that can actually code? Well, it turns out it's a pretty fundamental shift in thinking. The big takeaway here is a complete change in perspective. The planner and the improviser, they're not enemies, they're partners. They're actually two complementary stages in a single, much more effective training pipeline. You start with structure, and then you move to flexibility. This gives us a much more principled, logical way to build these incredibly complex agents. Instead of just throwing them into the deep end and hoping for the best, we can build up their foundational skills first, layer by layer. And think about it. This idea isn't just for software engineering. This whole stage training approach could be a blueprint for building more capable AI agents in pretty much any field you can imagine. Which leaves us with one final, really fascinating question. We've just seen how a bootcamp can prepare an AI for the field. Is this methodical, staged approach instilling foundational skills before granting full autonomy? Is that the key that will finally unlock truly independent AI developers? Well, the Kimi-Dev paper certainly suggests we're on the right track.